So we're going to talk correlation. And I want to start off by asking this question: which of these two data sets, the one on the left or the one on the right, seems to have a stronger correlation? And you may look and decide incorrectly because they're the same exact data set. Just one is zoomed in on the left and zoomed out on the right. But it's deceitful. I think this one looks like it's stronger, but in reality, they have the same correlation. And so if it's deceitful to just eyeball it, we want to have a numerical measure of correlation. And correlation measures the strength and direction. So strength, really, really strong, lined up nice and beautifully, or is it like all scattered all over the place? And direction, is it going up or going down, of the linear relationship between two quantitative variables. So it doesn't measure just like, is there a relationship? It measures the quality of the linear relationship. So if you have some points that line up in a curve shape, they're associated. There's a very clear relationship there, but you won't get a strong correlation because it's not a linear relationship, okay? Now, how do we measure it? So there's a spectrum, okay? Perfect correlation is 1 or -1. When you're at 1, it is a positive, or on the positive sides, it is a positive correlation, and you'll have a positive slope. If it is on the negative side, you have a negative correlation and a negative slope, all right? As you get closer and closer to 1, it's a stronger and stronger correlation. As you get closer and closer to 0, it's a weaker and weaker correlation. I like to think about it as A, B, C, D, and failing, okay? An A, a B, a C, and a D are kind of like the rating. So a 90 is an A, an 80 is a B, a 70 is a C. And like as you get weaker, you get closer to 0. So this spectrum, it will be helpful for you when you're trying to decide the strength and direction. Positive or negative tells you direction. Closer to 1 or -1 tells you strength, all right? And it'll help you. You're going to try a game after this called Guess the Correlation, which is kind of designed like Mario Brothers and can help you with correlation, all right? Now, there's this wicked messy formula that is on your formula sheet, okay? And I can summarize it a little bit for you. It's literally the sum of the z-score of each x. So z of the x's, and it's each one, so x sub I, times the z-score of the y sub I all over n minus 1. So we're basically taking the z-scores. And the reason why this gets what we call correlation in positive and negative is because if you sort of think, okay, so look, imagine that all these were just lined up on a dot plot and gravity pulled them all down to the bottom. Where would the middle dot be? And maybe you'd say, okay, so let's say that this is the middle of my x's, okay? So things a little bit to the right have a z, or on this line have a z-score of 0. They don't affect the correlation at all. But things that are farther and farther to the right have a positive z-score, and things that are farther to the left have a negative z-score for the x's. And then we similarly, if we had everything just magnetized to this left side, then you'd see a distribution that might be normalish or something like that over here, and the middle of it would be about right here, okay? So as you go to the right, you see that it's positive x, or z of x, okay? And over here, it's like a negative z of x. And up here, it's a positive z of y. And down here, it's a negative z of y. And so when I take this point, it's a positive z of x times a negative z of y. So this is contributing a negative value. And then I add to it, oh, this is a positive z of x times a negative z of y. And this is a positive z of x, but it's almost times 0 for my negative z of y, but it's contributing a small negative value. This one that's on the line is contributing a 0. This one that's on the line is contributing a 0. And so what we see is these points that are a big number in the z direction and a big number in the y direction contribute a lot. And so this number contributes a whole lot to the argument. These ones that are either a 0 in the x direction or a 0 in the y direction don't contribute much at all. And so this guy is positive z for x and a positive z for y because it's up and to the right. And so we're multiplying a positive times a positive. So there's a few positives here and a few positives here, whether it's a negative times a negative, okay? But they get overpowered by all of these that are negative and all of these that are negative when I add them all together and then divide by n minus 1, okay? So that's why we end up getting a negative r value when we see this downward sloping curve, okay? And I'll let you guys fiddle a little bit more with this on your own, but z-score of x times z-score of y divided by n minus 1. And you can get this on your calculator. I'll show you how in class. It'll be awesome. All right, we'll see you later.